So this seems like a big problem. It's really not too bad. Okay. Here we're looking at titanium reacting with carbon and with chlorine gas. Okay. What we use titanium for is actually in a whole lot of different alloys. We use them in airplanes. We use them in, artificial limbs or any other kind of, metal that you might need in your body. We use it on our, all sorts of other kind of infrastructure, not as far as like major beams and support systems, but we use titanium so much. And the big reason why is because it's really, 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 really strong compared to its weight. And also, it doesn't really react too much, especially with the stuff inside your body. So, it's pretty cool. Okay. Now, we can actually get titanium tetrachloride, all right, from extracting it with from titanium oxide. Okay, so we got titanium oxide. We can get titanium tetrachloride out of that as long as we can react it with chlorine gas and carbon. And carbon, we call it coke a lot in this field. Okay, we're asked to find three things. We want to find the mass of chlorine that's needed to react with 1.25 moles of titanium oxide. We also need to find the mass of carbon needed to react with that much titanium oxide. And we also want to find the mass of each product, or the total product, formed by that reaction. Okay, so this will be a slightly longer video than normal, but it's actually a really, really good transition into what we're doing next. So, let's make sure our equation is balanced, and then we will go and look at each ABC part. So I've got one titanium and one titanium. I've got two oxygens and two oxygens. I've got one carbon and one carbon, and I've got two chlorines and four chlorines. So that's the only one that's not balanced. I can multiply this Cl2 times 2 to balance that up. Okay, so I've got 1, 1, 2, 1, 1 for my coefficients. All right, for part A, what mass of chlorine gas is needed to react with 1.25 moles of titanium oxide? So here, I've got a number unit substance. That's what I know. And here I'm asked to find the mass of chlorine gas required. Okay. So for part A, I'm going to take what I know. So the 1.25 mole of titanium oxide, which is TiO2. And I want to convert to mass of chlorine. Okay. So I don't want to talk about moles of titanium oxide, so let's go ahead and get rid of that by putting it in the denominator. Okay, so now my moles of titanium oxide cancel. I want to talk about chlorine gas, and I know that if I'm canceling moles of one substance, I can convert to moles of the other substance, which chlorine is a different substance, by using the mole ratio, so let's go ahead and do that. Okay. However, I'm being asked to find the mass of chlorine, not the moles, which means I need to cancel out the moles of Cl2 by putting that in my denominator. Okay, so now I know my moles of Cl2 cancel, and I know that I can convert between the moles and mass of one substance. So I'm going to go ahead and put that up top in my numerator. And my moles of titanium oxide cancel, my moles of chlorine gas cancel. Now I'm left in grams of chlorine. So I'm going to go ahead. That's exactly what I was asked to find. So I'm going to put that in my answer. Okay. I need to fill out my conversion factors. Here, I know this my mole ratio here I can get from the balanced chemical equation. I see here that there's 2 moles of Cl2 required to react with every 1 mole of titanium oxide. So I've got 2 moles chlorine for every 1 mole of titanium oxide. And right here, this is moles in mass, so I need to find the molar mass of chlorine. Okay. So as a little aside, the molar mass of Cl2, I've got chlorine, whose molar mass is 35.45 grams per mole. And I've got 2 chlorines, or 2 chlorine atoms, or 2 moles of chlorine atoms for every 1 mole of Cl2. Okay, so that's going to give me 70.9 grams per mole as the molar mass for diatomic chlorine, meaning that there's 70.90 grams of Cl2 for every mole of Cl2. Okay. At this point, I can go ahead and multiply straight across because my denominators are all 1, so I'm going to take 1.25 times 2, and then I'm going to multiply it by 70.9. I get 177.25 grams of chlorine required. Okay, so if I've got 1.25 moles of titanium oxide, I must have this mass of chlorine to react with it according to this equation. Okay, so we found part A. Let's find part B. Okay, again, I'm starting with 1.25 moles of titanium oxide, and I'm being asked this time to find the mass of carbon needed. Okay, so here, instead of using green, I'm going to use purple. Just kind of help split it up. Okay. Yeah, you can tell. Okay. All right, so I'm going to begin with what I know, 1.25 moles of titanium oxide. I don't want to talk about titanium oxide anymore, so I'm going to use dimensional analysis, put moles of titanium oxide in the denominator. Okay, that way my moles of titanium oxide cancel. Again, this is a great point to convert now from one substance to another. So I want carbon, I'm talking about titanium oxide. This is a great place for me to use my mole ratio to convert into moles of carbon. Okay. However, I'm not asked to find moles of carbon, I'm asked to find mass of carbon, but at least now I'm in the right substance. So let's go ahead and say, well, now I know that I can convert from moles of carbon, that way my moles cancel, into the mass of carbon. So I'm going to put grams of carbon on top. Okay. So my units cancel the way I need them to, so I'm going to go ahead and write grams of carbon, because that is what I end up with in my answer. Okay, I'm going to use the mole ratio here. I'm going to get the numbers from the coefficients in my balanced chemical equation. I say that there's 1 mole of carbon required for every 1 mole of titanium oxide. So 1 and 1. Okay. And right here, I need to convert between moles and mass, so I need to use the molar mass, in this case, of carbon. Now, carbon is just an element. Okay, it's not Cl2, or it's not, there's no subscripts, there's no other elements, it's literally just straight up, carbon. So I'm just going to take the 12.01 as the molar mass. Okay, and I know that carbon weighs 12.01 grams for every mole. Okay, so to calculate this now, I'm going to take 1.25 times 1, so I'm just going to skip this step since it is all 1, times 12.01. So 1.25 times 12.01, I get 15.01 grams of carbon. So if I have 1.25 moles of titanium oxide, I need to react it with 15.01 grams of carbon and 177.25 grams of chlorine. Okay. All right, let's grab a second sheet of paper. Okay. Now, to find the answer to part C, we do a couple things. So I'm actually going to do 2 things and compare. Okay. In order to find the mass of all products formed by the reaction of the same starting material, okay, I need to figure out the mass of each product formed. So I'm going to do these 2 problems here. So for part C, okay, I'm going to first find the mass of titanium chloride produced. So I'm going to take what I know, 1.25 moles of titanium oxide. I want to convert out of titanium oxide and into, in this case, titanium chloride. Okay. So I'm going to titanium tetrachloride. Okay, here I'm going to put the moles of titanium oxide on the denominator. I'm going to put the moles, excuse me, because I can use my mole ratio, of titanium tetrachloride on top, or in the numerator. Okay, this cancels the moles of titanium oxide and converts between titanium oxide and titanium tetrachloride. Converts me to moles of titanium tetrachloride, but I want to find the mass. So I'm going to put the moles of titanium tetrachloride on the bottom. Okay, and that way they cancel, and put the grams of titanium tetrachloride in the numerator, because that's what I want to find. Okay, so I'm going to go ahead and put that in my answer. Alright, and then do the math. So I'm going to take, I need to fill in my conversion factors here. So I need to take the coefficients from the balanced equation. I see that there's 1 mole of titanium tetrachloride formed for every 1 mole of titanium oxide that reacts. Here I need to get between moles and mass using molar mass of titanium tetrachloride. So I'm going to take the mass of titanium and the molar mass of chlorine. Okay, I know that chlorine is 35.45 grams per mole, and I've got 4 of them. Okay, titanium, if you look on the periodic table, is 47.87 grams per mole, and I've got 1 of them. Okay, so let's try to figure out what this is. So it's going to be 35.45 times 2. Excuse me, times 2 again, because it's times 4. So 141.8 grams per mole. Okay, if we add those together, we have a mass of 189.67 grams per mole for titanium tetrachloride. Okay, so there's that many grams in 1 mole. So 189.67. Okay, and now I can complete the problem. Okay, so I'm going to take 1.25 moles of titanium oxide, multiply the 1-to-1 ratio here, so it's just going to be the same number to get me into moles of titanium tetrachloride, then multiply by 189.67. This is going to give me 237.09 grams of titanium tetrachloride produced. Okay. Now that's only one of the products. I need to find the mass of the other product as well. Okay. So let's grab another piece of paper, that way we can keep everything in view. Okay. I'm going to take same information that I'm starting with, so still starting with 1.25 moles of titanium oxide. I don't want to talk about titanium oxide anymore. Now, in this case, I want to talk about carbon dioxide. Okay, I know that I can get out of moles of titanium oxide and into moles of my other substance here at this point using my mole ratio. Okay, that'll cancel out the moles of titanium oxide and leave me in moles of carbon dioxide, which I don't want. I want mass of carbon dioxide. So I'm going to need to continue the problem and put the moles of carbon dioxide in the denominator so that they cancel. Alright, and I know I can convert between moles and mass of the same substance. This will give me the mass of carbon dioxide. Okay, everything cancels right and leaves me in grams of CO2. So I'm going to go ahead and write that in my answer. Let's get the mole ratio from the balanced equation here. So I've got 1 mole of carbon dioxide produced for every 1 mole of titanium oxide. And now I need to figure out what's going to get me between moles and mass. So that's going to be molar mass of carbon dioxide. Okay, so I've got carbon and oxygen. Carbon is 12.01 grams per mole. Oxygen is 16 grams per mole. Got 1 carbon and 2 oxygens here. Okay, so 32 grams per mole. Okay, if you add those together to find the molar mass of the compound, you get 44.01 grams per mole. Now, some of y'all might already have that memorized since we've used this so much. If not, just another refresher on how to find it. Okay, that means there's 44.01 grams of carbon dioxide for every mole of carbon dioxide. Okay. We can then do the math. So I've got 1.25 times 1 over 1 times 44.01. So I'm just going to do 1.25 times 44.01. This gives me 55.01 grams of carbon dioxide produced. Okay. So if I want to find the mass of all the products, the total mass of the products formed, I can take the mass formed of one product and add it to the mass of the other. So this plus that equals total mass of product, which would then be, put that up, 237.09 plus 55.01 gives me a total mass of 292.1 grams. All right, that's just one way to find this, okay? We could actually do another thing, okay? So let me bring you back to the beginning, where in parts A and B, we were asked to find the mass of the two reactants that react with titanium oxide. So we found the mass of this reactant, the mass of that reactant, okay? Well, according to the law of conservation of mass, the total mass of my reactants must equal the total mass of my products. So since I've already found the mass of two things, I only need to find the mass of one more. I could, for part C, have just taken the moles of titanium oxide and seen how much mass that would be. So I could still start with 1.25 moles of titanium oxide. Since I don't want to talk about moles of titanium oxide anymore, I want to cancel that by putting it in the denominator. Okay, and I know that I can find the mass that this would be by going ahead and putting grams of titanium oxide on top. So now instead of talking about moles of titanium oxide, I'm talking about the mass of that amount. So this is the mass of one reactant, mass of another. This would give me the mass of my first reactant. So that's going to give me grams of titanium oxide. Okay. Now, in order to convert between moles of mass, I need to find the molar mass of titanium oxide. Okay. So, to find the molar mass of titanium oxide, I'm going to take titanium, I'm going to take oxygen. Okay, titanium we said was 47.87 grams per mole. Oxygen is 16 grams per mole. I've got 2 oxygens, okay, and 1 titanium here. So it gives me 47.87 grams per mole plus 32 grams per mole, which will give me 79.87 grams per mole for titanium oxide, meaning there's 79.87 grams of titanium oxide for every mole of titanium oxide. Goes my lights again. Okay. So if 1 mole weighs this mass, 1.25 moles should weigh 1.25 times that mass. So 1.25 times 79.87 gives me 99.84, grams of titanium oxide. Okay. And so this is the mass of one reactant, mass of the other, mass of the other. So the total mass of my reactants will equal the sum of these three numbers. So I can add all that up. I get 177.25 plus 15.01 plus 99.84, that's 88, 99.84, get 292.1 for my total mass to begin with. And the law of conservation of mass says that that total mass has to equal the total mass of my products formed. So we could have just done this one calculation and added parts A, B, and C together to answer, actually the total answer for C. But it would have been perfectly fine for you to find the mass of each individual product formed and then add them together. And look, you get the same number either way. And that's because of the law of conservation of mass.